Okay, we are going to start talking about, or continue talking about polynomials and start with section 6.2, polynomials and linear factors. And we will begin starting by talking about end behavior. And in an Inspire activity, you will work on analyzing the factored form of a polynomial and writing a polynomial from its zeros. And then we'll also discuss how to find the relative max and min, which you will also use the Inspire to do. So first, let's talk about end behavior. So when we are looking at a polynomial, before we graph anything, even if we use a calculator, we still want to kind of know what we expect to see, so we know generally if our graph makes sense. So end behavior is a really good thing to look for. And the end behavior simply describes what the graph is doing on the far ends. So way at the left and way at the right, not what it's doing in the middle, just what it's doing on the ends. And you can determine the end behavior just by the leading term. You don't have to know, doesn't matter about the rest of the terms, just the leading term. And remember that the leading term means the term that has the highest power. It may not actually be written in front when you first look at it. It's the one that would be in front if we put it in standard form. That leading term could have an even power, like x to the fourth. And then it could have either a positive coefficient in front of it or a negative coefficient. If it has a positive coefficient, the two ends are going to go up on both sides. So they're going to be the same and they're both going to go up. If it has a negative coefficient, then both ends are going to do the same thing and they're both going to go down. And those arrows are just how we write end behavior. So when you work a problem that has to do with end behavior, they're simply looking for those two arrows. We can also have an odd power, like x cubed, like the example that you see below. And if we have an odd power, we can again have either a positive coefficient in front of it or a negative. If it has a positive coefficient, then that means it will be down to the left and up to the right. And if it has a negative coefficient, it's basically flipped over. So it will have up to the left and down to the right. And you should have noticed that in the Inspire activity if you've already done that. There were some examples of that. So let's look at the example that's written right there below. Y equals 3x minus 4x cubed. Well, first of all, let's actually circle the leading term. And this is what you should do on any problem that asks about end behavior. Just circle the term that you care about, which is the leading term. And that's this term. Even though it's not in front, if we wrote it in standard form, we would write negative 4x cubed plus 3x. So this is our leading term. In that leading term, you have the degree, and you have, sorry, my pen went a little crazy there. You have the degree, and then you also have the coefficient. And the coefficient is simply the number that's in front of your variable. So this one has an odd power, or an odd degree, and it has a negative coefficient. So that means that you will have the far right of your table there, and it will look up to the left and down to the right. And you can type that into your calculator to see what that looks like and verify that it does go up on the left and down on the right. So that's about end behavior. Now you need to work numbers 1 through 10 on page 312, and you want to do that without graphing. So we'll do one of the problems here, and you can actually do it on this notes page, or you can do it on another piece of paper. So for example, here's number 1. We want to write the problem down, y equals 3x plus 2. You want to circle your leading term, and then you're simply going to draw your end behavior. This degree is 1, and the coefficient is positive, so it has an odd power and a positive coefficient. So the end behavior is down to the left and up to the right. And that's it. That's all you're going to write for all 10 problems. Just write the problem and then draw the end behavior and do them without graphing. So you can pause at this time and you can go ahead and do those 10 problems and then start the lesson again. Okay, well, hopefully you've done the end behavior problems, and now we'll talk about continuity. We have only really worked with what are called continuous functions, and a continuous function has no break in its domain, which means it has no gaps, no holes, no jumps, no steps. A discontinuous function obviously has a break or breaks, could be more than one in its domain. And we will deal with those type of functions later. And so we'll talk about what those would look like at another time. So right here on your notes page, I want you to go through and just sort of summarize what you learned in the activity about zeros and multiplicity before you go on to the next part where we'll use that information. So just take time and write a little bit about what you learned on that activity, and then pause, write that down, and then start it again. Okay, the last things that we want to talk about, or next thing we want to talk about, is relative maximum and relative minimum. And we've already used the trace feature to find a maximum or minimum, but we've been doing parabolas which have what we call an absolute maximum or minimum, and that's the biggest value that the function ever has, or the smallest one. Well, relative maximum or minimum, and you can see the chart there that you have on your notes, that's basically in a little area, it's the largest or smallest point that you would have. So you have basically bumps. They're high points and low points, peaks and valleys, and those values would be the relative minimum or relative maximum. And just like we answered before, the maximum or the minimum is the y value, because y measures how high and low things go, and that's what we mean when we say that, how high or low the function went at that point. That graph also reminds you about the x-intercepts and shows you those in green, and that is where y equals 0 if you're on the x-axis. So the x-intercepts, or to find the relative max and min, can be the same way we find the x-intercepts. You can simply use the trace feature on the inspire, or you can use analyze graph. Either of those will work to find those places. The factor theorem relates those zeros to a factor. So it tells us that x minus a is going to be a factor of the polynomial if and only if a is a 0. If and only if means this is true both directions. X minus a is a factor if a is a 0. Alternately, a is a 0 if x minus a is a factor. And that's what you're going to be using to answer a lot of your questions like you did on the Inspire activity. So let's look at the last part here. My graphs look a little different than yours. I took them off of two different places to make the worksheet and to make this. But here you have 6 different graphs. And so we're going to look at the key points here that help us write these functions factored, which is part of your homework. So if we look at the first example, the x squared minus x minus 6, you can see that it has zeros here where I've circled. So it has zeros at x equals 3 and x equals -2. Well, that means the factor theorem says if 3 is a 0, then x minus 3 is a factor. And if -2 is a 0, then x minus -2 is a factor, but minus negative means plus. And so we could factor that polynomial just like that. So let's go to the next one. So if we look at the next example, there's only one 0, and that is at 3. But we also know that there have to be as many zeros as there is power. So there have to be 2 zeros. And you also learned in your activity that if it bounces on the graph and just touches it, then that 0 occurs twice. So here, x equals 3 is a 0 with multiplicity 2. That 0 happens 2 times. So that means we could write x minus 3 times x minus 3, and that would equal that polynomial. The third example, if we're looking to try to write this in factored form, well, we look to see where does this graph cross the x-axis. Well, it doesn't cross the x-axis. So this one cannot be factored. There aren't any factors, and that's basically what that theorem is telling us. Unless it crosses, if there are any zeros, there can't be any factors. So no zeros, no factors. All right, so let's look at the bottom one on the left. We have zeros at 3, 0, and 1. There are 3 zeros, and it's x cubed, which means that each one occurs only one time. So you have zeros of -3, 0, and 1. So to factor it, it would be x plus 3, x minus 1, and then x minus 0, which would really just be an x. And I should have left room. I'll scoot this over. Really, we would just put that in front because subtracting 0 doesn't do anything. So this is the polynomial in factored form. Next example, we only have a 0 at -1. And this one would be more complicated, and we're going to save that for another time. But you know you have a 0 at -1, which means x plus 1 is a factor. And so we would have to use synthetic division, divide, to find out what's left, because there would be other factors there. Or in this case, what we would find is x plus 1 is actually a factor 3 times. So it's x plus 1 cubed. And then on this last example, we have a 3 as a 0. So again, x minus 3 is a factor. In this case, we would use synthetic division to find out that the remainder that we have left does not factor, and that's what we would get using synthetic division. And one more comment, and that is all of the things that mean the same thing, and this is over on the left-hand side of your notes. If we just take that very first example that had a 0 at -2 and +3, let's just take the number -2. We can say -2 is a solution of x cubed or x squared minus x minus 6 equals 0. We can say -2 is an x-intercept, -2 is a 0, -2 is a root, or x plus 2 is a factor. And all of those are essentially the same thing. So if somebody asks you to find the roots, the solutions, the factors, the x-intercepts, or the zeros, you're going to look on the x-axis and see where it crosses. And they all basically mean the same thing. And that's it for this lesson.